So we are going to wrap up our model of the atom today. We are going to be looking at the quantum model of the atom. We're going to start our discussion by looking at the scientists who made contributions to the quantum model of the atom. So here's where we left off. We left off by talking about the fact that we believe that electrons have a dual nature, which means they can behave as a wave and a particle. And so we really needed some evidence for this. So the first piece of evidence came from a scientist by the name of Louis de Broglie. And he pointed out that electrons in Bohr's model was similar to the behavior of waves. So he treats electrons as waves. And he also believed, like Bohr did, that electrons can be found at different distances from the nucleus. So some parts of Bohr's model holds true in this quantum model. And so the closer electrons are to the nucleus, the lower their energy. The further away from the nucleus they are, the more energy they have. So de Broglie suggests that electrons can be considered waves. So that's what we see in this image here. And they're confined to a certain space. Okay, so we're no longer thinking of orbits anymore. And these electron waves could only exist at certain frequencies. So in other words, they had to have a specific amount of energy. And there's also other evidence that shows that electrons behave like waves, such as they can be bent. So just like light bends, light can be diffracted. So that's another property that we see. Right. All right, the next scientist we're going to talk about in terms of the quantum model of the atom is Werner Heisenberg. So then the next question became this. If electrons have a dual nature, can behave like a wave and a particle, then where are they in the atom? So Heisenberg's idea involved detecting electrons. And he said the easiest way to detect electrons is by looking at their interaction with photons. So we remember that a photon is a particle of energy that has a specific wavelength, frequency, and energy. Now, here's the difficulty. Because these photons have the same energy as electrons, if you attempt to locate a specific electrons, this photon would then knock the electron off of its course. So in other words, there's an uncertainty in trying to locate an electron. So the Heisenberg uncertainty principle states that it's impossible to simultaneously, so that means at the same time, determine both the position and the velocity. You may know that as speed of an electron. Okay, and then this brings us to the last scientist we want to talk about in terms of being a contributor to the model of the atom, and that is Erwin Schrödinger. And again, we're talking about electrons having a dual nature of being behave as a wave and a particle. And Schrödinger developed an equation, and he treats electrons as waves. So here's what he says. So he treats electrons as waves, and only waves of specific energies. And if they have a specific energy, they would then have a specific frequency, provided solutions to what he called his wave equation. So in his wave equation, he basically tells us that electrons have a certain probability of being found in orbitals. So that's really the key term here for the quantum model at various distances from the nucleus. So again, we still believe that the closer an electron is to the nucleus, the lower its energy. The further it is from the nucleus, the higher its energy. And so here's the picture of Schrödinger's model of the atom based upon his wave equation. Okay. All right, so we are actually going to wrap up this part of our lecture by defining an orbital. So an orbital is going to be a three-dimensional region around the nucleus. That indicates the probable location of an electron. Okay. So no longer orbits where electrons are following this very specific path. We now have these three-dimensional regions where electrons are in constant movement within those regions, and those are known as orbitals. And so this quantum model of the atom is described by what we call the quantum numbers. So the quantum numbers, there are four of them, and that'll be the next part of our lesson where we look at the four quantum numbers and what they tell us about electrons.